Hello everyone, welcome to TryRide, the new era of learning. This is Pack 365 in Module 4. Today we're going to learn about propositional logics in artificial intelligence. Let's move to the topic. Propositional logic in artificial intelligence. Propositional logic is used for solving complex problems using simple statements. Those statements can either be true or false, but cannot be both at the same time. Those proportionals from the knowledge, representation, reasoning, and decision making in AI systems. So, we have some proportional logic in artificial intelligence, right? So, the proportional logic is a fundamental tool used in artificial intelligence AI for addressing the complex problems. It does not it does this be breaking down complex information into simple statements, like it has a key characteristics of the truth values, like each statement can be definitely classified as either true or false. So a statement cannot be both true and false similarly. This is a core principle of the classification logic. So we can say that the logic of the representation. So, uh, purpose of providing a structured way of AI systems to represent the knowledge about the world instead of storing information as free from text. It's broken down into a discrete verification statements. So, basic of proportional logics. I would like to cover the syntax, how to write a proportional and semantics, and how to assign the truth values, and foundational logics can consider and or not implies, like, okay. So let's start the exploring. So here we have semantic and syntax, right? Syntax and semantic. So in syntax, the rules for how to take generate complex claims from the simple ones. Semantic, the meaning of the atomic units, and the ruling rules governing how the meaning of the atomic unit are put together from the complex meanings, right? So, syntax of PL and professional logic, and here using a logical connectivity and the operators which connect or operate on the propositions like use. So here we can say, in simple terms, we can say the rules of the for how to take a generate complex claims from the simple ones. In a similar term, syntax refers to the grammar or structure of a logical language. It indicates how you can climb or how you can combine a basic components using a specific symbols and the rules to the from well-formed complex logical expressions. It about how to write and valid logical sentence, not what they mean, right? So in semantic, we can say that on the other hand deals with a meaning to interruptions of those well-formed logical expressions. It about the assigning the truth value, true or false, to the individual statements, and then determining the truth value of a complex statement based on one truth values of the parts and the rules of the logical connectivities. So, syntax professional logic using the logical connectivity and operation. Those are the clue that can combine simple proposition into a more complex one. Their operands can be propositions. So we have the symbols, letters like P, Q, or an X or Y, Z. Those are used to represent the specific atomic statements of the or prepositions. For example, P might stands for it is raining, and Q might stands for like the ground is wet. So like that unary position. So the symbol often though read has not. It's not it is a unary operator, meaning its operator only is a single proposition. If P is true, then not P is false, like that, vice versa. So binary opposition, like we have the binary proposition connectivity here. So binary proposition connectivity, the binary operators meaning they connect two propositions, we can say that often as implies or if then. If then P implies Q, like that, and we can say both by condition two here. So overall, the common syntax is it provides the blueprint for the building logics, sentence and semantics, assign the meaningful those sentence, allowing test, determine the truth. So here we have negation. Negation P is nothing but not P. Okay, not P, which means so if it P is true, it opposite to the truth value. Conjunction. Conjunction is nothing but we have the proper value of and, right? Conjunction, we have an end. We have to statement. We have to like we can say here. So negation nothing opposite of p. So if the p value is true, so the negation p should be false, because if the value of the negation is true, so it's opposite to the value, not true or not false. Okay. So conjunction. So when it comes to conjunction is nothing but and. We use and operator, right? So and is nothing but it is a conditional based operator. So for and, if we have conditional based, like I want to buy a car in showroom, like we have condition, like we have I want to go to college and write the exam. Like condition, I want to go to college is P. I want to write the exam like Q. So both are must and should. We want to do that, right? So in that condition, we use condition based, right? Here condition and we use condition based PQ. And next, disjunction. So here disjunction is nothing but it is or based, like it's optional based. Like we want to choose either this or another. If we have true or false, either one must be true in conditional disjunction, right? Either one must be true or this or neither this. If any value has a truth, it may be true. Like if we have true, here we have true. Like example, we can say here. Uh, any value can true. Like I have a exam paper, like I have a question paper, and I return the answer here. I return those all answers, right? So we have both conditions, right? So it is must be true. And next we can say that in true, we can say that false here, because I had question paper, but I didn't write the answers, because here we have question paper is satisfaction or answer, right? So we want question paper here. So any must be true, either optionally. So I have question paper, I didn't answer others. So like that is basically optional. Any must be true. One of the optional must be true in here. So overall material condition is the same, but if we use the then, like we directly supposed to the Q. Okay, directly lies to the Q. Like by condition also, like if the both condition has true, like if the by condition we have, so both statements were true, it must be true. Either it satisfies the both conditions. If we have false, so the condition must be also false. Sorry, the condition must be also true, because we want to carry the both conditions, right? Each and every condition must be same implied same. Now moving to next. So semantic PL. So here we can see semantic PL. So in semantic PL, we can say that semantic rules of the PL tells us to how to meaning of the its continued parts under the mode and the combination of determining the meaning of the compound statements. Logical operator in PL determines what the truth value of the component statements are depending on the truth value of the formula in the component. So here we have logical operators like true has a true, F has a false. So P negation P. So here we simply discuss it if the value of the so like we previously we discussed about so if the P is negation P, so negation is opposite to the truth value. If we have truth value in P, so it opposite to the false value. Like that, if we have false value, it changes into the truth value. And here conjunction. So we discuss about the conjunction, right? So we must be satisfy the conditions, right? So conjunction. In conjunction, we must be satisfied the conjunction. So conjunction element P and Q. P and Q. We must satisfy those both conditions, right? We must satisfy the both conditions, right? Like we can say that one of the condition here we satisfied. Like we take bride and groom. So you have bride and groom. If we can get married. If you have only groom, only bride, we could not marriage, right? We could not done marriage. So it is false. So I'm taking the for Like this is bride and this is groom. Okay. So we're taking conditional here, conditional operator. P has a bride and Q has a groom, right? So we have bride and groom. So we can easily get married. So we have only one person here. So we could know the marriage not existed. Even through if a groom not if it, then also we know. So in simple terms we can say that. So if we have a boy and girl, then we can easily get married, right? We have conditional. So if we only boy existed, does not girl does not existed here to married, so we cannot get married here, right? False. So if the boy does not existed, girl is existed, so then also we cannot do married because both we want to satisfy the both conditions, either true. So here both are not that, so marriage is nothing. So false. So only where the both conditions were satisfied to the truth values, connection values, so it must be true. So disjunction. So it's we discussed about the disjunction. It is an optional based. Disjunction is nothing but it is a optional based, right? So either this or neither this. We have to satisfy any of the truth in P or Q. Any of the condition we must satisfy the truth. Like if we have both in one true, it must be true to the value, right? Like to today I'm going to school, like satisfy any condition, like today is raining and the land was wet, like the sun it's cast like satisfying the condition today is raining, land is not wet. In some conditions land is not wet, there is no raining, still land is wet. Like we can say that if you're cleaning purpose also we can do land wet. So like the conditions we can satisfy, we any one of condition and optional we must be satisfied. So in those material conditions, so if material condition is one of the implement conditions. So here we can say that, so truth, like the truth semantic of the defines the truth value of the implement conditional true. So all possible combinations, like if we have ascending concept, like we have truth, truth means truth, and only where it gets false if the condition lies on true and false. So at the condition, it must be given as false, right? So like in take example, if the rain is if it is raining, right? And if it is raining, then the ground is not wet, is F. So how should it, in the case of whether a material condition is false? So it made by if group. So we can see only in the condition of true or false condition, it may be get false. In the remaining all the conditions, it implies to true by conditional. So by conditional, nothing but we want to satisfy any of the condition. Both we have to satisfy the both condition has the same. Okay, in some case, in such cases, the biconditional must be represented like this also. So don't be confused. So within some cases, the biconditional must be represented like also the symbol. So don't be confused. So here we want to satisfy this and this. We have to satisfy the both the P and Q. It is same constant identity values. So truth, truth means truth. False, false means also false. So the simplest and the most abstract logic we can study in called propositional logic definition. A proposition is a statement that can be either true or false. It must be one or other, and it cannot be both. Right? Example, like the reactor is on. Like here we can say the reactor is on. Like we must can say the reactor is on means the reactor is true because the reactor is on. Like we can say, okay, the reactor is in on. True, we consider true here. The winds flaps or up, so it is false. John Major is a prime minister. So here we can say true or false. Like true means we know the John. If we know the John, he is a prime minister. So we can consider it is true. So we don't know the John and he is telling prime minister. So it can be false. So both conditions will satisfied here. So whereas the following or not, are you going out somewhere? True or false. Here also implies the true or false because we don't know if we are conditional based. Here 2 plus 3 equal to if we have 5, it means true. If we have negation, uh, negation P, if we have, we can consider as false. We had more example, don't worry. So, the conjunction denoted by the and, right? The symbol of it's for and assign it. It is a Monday and it is raining. So we want to satisfy the conditions and detention. So detention, it is Monday or it is Tuesday. So optional basis we choose. So denoted now negation denoted by dash. So it is not case that is Monday. So we opposite to the truth. Implication denoted by arrow or which condition truth has if condition. If it is Monday, then it is not to a weekend like that. So by condition, we can say that the truth value or the same as it assigned. It is weekend if and only if it is Saturday or Sunday like that. So here we can say that here we can see here. So statement one, we can say if I am sleeping then I go to bed. So we have a conditional base here. So why we can say here we have something little bit. So we have a conditional here. So how we denote the sentence like if I am go to the sleep, we denote this and this. So I denote this I am going to if I am going to sleep like if we have if here. So we can say I am going to sleepy like PQ and here we have then means of then if for we can have implementation conditional. So I am going to the bed I denote as Q. So like the sentence we can divide it easy. So for the final output we get like this. P implies Q is true and P is true, then the Q is will be true. So like that it implies. Since simplification rule states if P and Q is true, the Q then Q or P will also be represented can be as like this. So we have more examples like here. So P of P and Q like example, and either here we have P and Q or two prime. We can conjunction rules or divide P and Q. So we have some satisfying condition. He's studying very hard. He is the best boy in the class. So we studying very hard and he is the best boy in the class. So we have a conditional. So we can say that P he is studying as a P and he is the best boy of the class in Q. So therefore he study very hard and he is the best boy in our class. So like that condition. So if we use here bijunction, or sorry, if we use here disjunction, so we can say that it's not familiar. He study very hard or he is like optional. It's change the format of the sentence. So I hope you guys all are you understand about this concept of propositional logic. And thank you.